In early 2020, grocery stores across the developed world began to exhibit a strange and unsettling phenomenon. Shelves that were once reliably stocked with household staples suddenly stood bare. One of the most prominent and widely reported examples was the complete disappearance of toilet paper. Consumers arrived at their local supermarkets to find entire aisles empty, a sight that had not been witnessed on such a scale in generations. This was not a localized issue affecting a single town or city. It was a widespread disruption that rippled through nations, from major metropolitan centers to quiet suburban communities, leaving shoppers confused and anxious about the availability of a simple, everyday product. The scarcity was not caused by a sudden halt in production. The factories that produced toilet paper were, for the most part, still operating at full capacity, churning out rolls just as they always had. There was no fundamental shortage of the raw materials needed, nor was there a catastrophic failure in the machinery required for manufacturing. The system, from the forest pulp to the factory floor, was functioning. And yet, despite the continuous output from producers, the retail end of the supply chain had completely broken down. The product was being made, but it was not reaching the people who wanted to buy it, creating a perplexing and frustrating disconnect for millions of consumers. The situation presented a stark contradiction that defied simple explanation. On one hand, the global manufacturing and logistics network was celebrated for its incredible efficiency. For decades, this system, often referred to as just-in-time, had been perfected to deliver goods from producers to consumers with remarkable speed and minimal waste. It was designed to keep costs low by ensuring products arrived precisely when they were needed, eliminating the need for expensive, space-consuming warehouses filled with excess inventory. The success of this model was visible every day in the full shelves and vast product variety that consumers had come to expect as normal. On the other hand, this highly optimized system proved to be incredibly fragile when faced with a sudden, unexpected surge in demand. The very mechanisms that made it so lean and efficient also made it vulnerable to shocks. The empty toilet paper aisle became a powerful symbol of this hidden brittleness. It raised a critical question that went far beyond a single product. How could a system so advanced and so meticulously designed for performance fail so completely and so quickly? The answer lies not in a single point of failure, but in the complex, interconnected structure of the entire global supply chain itself. The system responsible for both the abundance and the occasional scarcity seen on store shelves is commonly known as just-in-time, or JIT. At its heart, JIT is a production and inventory management strategy. Its primary goal is to increase efficiency and minimize waste by receiving goods only as they are needed in the production process or by the customer. This approach stands in direct contrast to older just-in-case models, where large stockpiles of materials and finished products were kept in warehouses to buffer against potential supply or demand fluctuations. The core logic of JIT is to eliminate the costs associated with holding excess inventory, such as storage, insurance, and the risk of obsolescence. The participants in a just-in-time system form a tightly coordinated chain: supplier, manufacturer, logistics, retailer, customer. Raw material suppliers provide the basic components for manufacturing. Suppliers deliver materials directly to manufacturers. Manufacturers produce finished goods. Logistics moves goods. Trucking companies, shipping lines, air freight services. Goods go to distribution centers or directly to retailers. Finally, retailers make the products available to the end customer. The just-in-time system operates as a pull system rather than a push system. In a traditional push system, manufacturers produce goods based on a forecast of future demand and then push that product down the supply chain toward the consumer. A pull system works in reverse. The entire process is triggered by actual customer demand at the retail level. When a customer buys a product, that sale sends a signal backward up the supply chain. The retailer orders a replacement from the distributor orders from the manufacturer orders raw materials from its suppliers. Nothing is made or moved until a sale has signaled that it is needed. This flow of information is just as critical as the flow of physical goods. Modern JIT systems rely on sophisticated digital tools to function. Electronic Data Interchange, or EDI, enables automated instantaneous communication of orders, invoices, shipping notices. Advanced demand forecasting software analyzes historical sales data and market trends, helping to fine-tune the signals sent up the chain. That creates a synchronized dance where every component arrives precisely where it's needed, exactly when it's needed. For a just-in-time system to deliver on its promise of efficiency, it must operate on a foundation of several critical assumptions. The first and most fundamental assumption is that of reliable demand forecasting. The entire pull system is predicated on the ability to accurately predict what customers will want to buy, and in what quantities. The system assumes that customer behavior is relatively stable and that any fluctuations will be minor and predictable. It is not designed to handle sudden, massive, and unforeseen swings in purchasing habits across an entire population. A second core assumption is the existence of stable and predictable lead times, ensuring that a new shipment will arrive just as the last of the old stock is being used. This delicate timing leaves no room for unexpected delays, production problems at a factory, a traffic jam on a highway, or a container ship getting stuck at a port. The third crucial assumption is supplier flexibility and reliability. The system assumes that these suppliers will be able to ramp up their production quickly and scale down their production quickly in response to changes in demand signals. It also takes for granted that these suppliers will not face their own disruptions, labor shortages, natural disasters, or geopolitical issues. The network is only as strong as its most vulnerable link, and JIT assumes every link is consistently strong. When these conditions hold true, the system performs flawlessly, delivering lower costs, fresher products, and greater choice. However, these assumptions also represent the system's inherent vulnerability. The question that remains is what happens to this highly optimized system when the stable world it was designed for suddenly disappears. When just-in-time systems falter, the causes often appear obvious. First are demand shocks. During the 2020 toilet paper shortage, panic buying created a massive demand spike. The lean JIT system, with no extra inventory, couldn't absorb it, and shelves went bare. Second are supply shocks. The 2011 Tohoku earthquake in Japan shut down key component suppliers, halting car production lines worldwide for manufacturers who relied on a single source. Third are logistics bottlenecks. In 2021, massive port congestion left ships full of goods anchored offshore, unable to enter the domestic supply chain. These surface causes are compelling, but they are symptoms, not the disease. An empty shelf is a symptom. The disease is a system designed with almost no buffer stock. To understand this fragility, we must look beneath the surface. Several hidden drivers make supply chains fragile. First, financial incentives reward minimizing inventory, as buffer stock is seen as wasted capital. This drive for efficiency also encourages single sourcing to cut costs, creating hidden vulnerabilities. Second, the bullwhip effect, where small changes in retail demand amplify into massive swings upstream as each participant adds their own safety margin. Long shipping delays mean decisions are based on old information, creating a system that is always looking in the rearview mirror. Finally, just-in-time systems are tightly coupled, like cars driving bumper to bumper at high speed. With no buffers to absorb shocks, a single disruption can cause a catastrophic pileup. Finally, a subtle but powerful driver is the way globalization creates an illusion of safety through risk pooling. While factories may be in different countries, they often rely on the same Tier 2 and Tier 3 suppliers for critical raw materials and subcomponents. For example, auto manufacturers may have assembly plants in the United States, Germany, and Japan, but all of them might source a specific microchip from the same factory in Taiwan. The risk has not truly been pooled. It has simply been concentrated further down the chain, hidden from view. A disruption to this shared infrastructure, such as the blockage of the Suez Canal or widespread port congestion, affects everyone simultaneously. The risk is not diversified, it is shared. Companies believe they have mitigated risk by spreading their operations globally, but in reality they have swapped a series of smaller, independent risks for a single, massive systemic risk. The journey through the complexities of the just-in-time system reveals a fundamental truth: the empty toilet paper aisle, the cars waiting for microchips, and the ships anchored at sea. They are the predictable outcomes of a system designed with a specific set of assumptions. It operates with breathtaking efficiency when demand is stable, suppliers are reliable, and logistics flow without interruption. However, when those foundational assumptions break, the system's greatest strengths become its most profound weaknesses. The hidden drivers we have explored all work in concert. They take a small external shock and magnify it, sending waves of instability through the entire network. Efficiency, pursued as the ultimate goal, systematically strips away the buffers, redundancy, and slack that are necessary to absorb unexpected disruptions. The fragility was not an unforeseen side effect, it was the price paid for unparalleled efficiency. This deeper understanding leaves us with a critical and unresolved tension, a fundamental question about the trade-offs we are willing to make. Building resilience requires creating buffers, extra inventory, diversifying suppliers, building redundant capacity. These actions contradict maximum efficiency and mean carrying costs as insurance. This creates a difficult choice with no easy answer. Who should bear the cost? Individual companies, risking a competitive disadvantage, or public policy with governments mandating strategic reserves? The ideal balance may differ for a critical medical device versus a seasonal fashion item. The debate over the future of our global supply chains will be defined by how we navigate this unresolved tension. You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.